Greetings. It is our pleasure to welcome you to a series of videos that your professors Claire Chua and I will be producing to help you advance your learning in business statistics. This video focuses on the types of data that we can collect as part of surveys or other instruments to collect data. You could see that this is a survey from a company that wants to improve the working conditions of the employees who work there, and there are some questions. For example, how often do you come to work? And the responses could be every day, maybe 4 to 5 times a week, and so on and so forth. Or how would you rate your these products, whatever could be there? Are they maybe it's your coffee. How do you rate your coffee? Is it consistently high quality, generally good, quality varies daily, or is it poor quality? So you could see that these questions are asking people to respond, and there are some categorical categories available to you to respond to. So that brings us to this question of what type of data are there, and is there a particular set of data or particular type of data different from others, and what are those differences? So consider this data set that you have in the first column, bank names. You could see that this information is names, and these are characters. We can also call this information it's qualitative, or it could be categorical. Again, another example is the online account access. Do you have access to your account online? And the responses are yes or no. It's a binary response, or we also call it a dichotomous response. But at the end of the day, it's a categorical response. Yes versus the other category, no. But what's in the middle? You have, as I said earlier, the bank names, which are categorical, and the online account access, which is categorical. But then in the middle you have the minimum balance, the monthly service charge, the background check fee, and foreign ATM fees. So there's data, these are dollars amounts here. What kind of data is this? And we call this type of data the quantitative data or numerical data, and this data differs from the categorical data that you see on the two sides. So in a larger classification of data, I would say that there are two types of data. One is quantitative, numerical, these are the dollar figures, and the other one is qualitative or categorical, that's the name of the banks, or are you happy with your coffee? Yes, no, maybe. So moving ahead with classification of data, types of data is one thing, and then the measurement scale. How do you measure this? So this is the rather technical definition of the variable. So if it's a qualitative or categorical data set, you could have two types. You could have nominal scale or ordinal scale. And I will give you an example. Let's say ordinal scale. You can say, how many siblings do you have? You may have one brother or sister, two brothers or sisters, or you may be the only child. So it could be 0 siblings, 1 sibling, 2 or more. There's an order in your response. Same is the case with how many bedrooms are in your house. You may have 1 bedroom, 2 bedroom, 3 bedrooms or more, and there's an order in it, and that type of data is ordinal. On the other hand, nominal data could be categorical data that has no particular order in it. For example, how did you come to school today? Did you walk? Did you bike? Did you take public transit? Or did you drive? Or was there another mode? So you have more than one category, 4 or 5 categories. But if you call one category 1 and the other one 2, or then reverse them, you wouldn't be making any mistake, because the categorical variable, that is the mode of travel to school, is essentially a nominal variable, and the order of those responses do not matter. Quantitative data, which is the numerical data, could be discrete and continuous, and on the measurement scale it's known as the interval or ratio data. Let me just focus for now on continuous data. Continuous data is your hourly wage or your annual income, your average GPA. These are continuous data. So let's begin from the very first stage of how we capture data, because in business statistics and business analytics and market research, you may or may not get your data in a file, in a computer file. you may have to generate it. And one way of generating data is conducting your own surveys. And if you were to conduct a survey, you can code the variable. So, for example, product quality, or how often do you come to school, or how do you rate this product. You can code them as 1, 2, 3, or 4. Some would be ordinal, some would be nominal. And then by coding this, it allows you to then summarize data. Because remember, if it is a categorical data versus continuous data, a different set of statistical analytics could be performed on them. Let's say we take the same data set, these two categorical variables, and enter them in an Excel spreadsheet. You could see that there are 15 respondents, and question number 1 is how often do you come to company or to your work, has been coded as categorically as 1, 4, 2, 5. And remember that 1 risk corresponds to every day, and 2 corresponds to 4 and 5. So 2 is 4 and 5, 1 is every day, and 4 corresponds to you come there maybe once a week. So this is a categorical response where 4 doesn't mean 4 times a week and 2 doesn't mean 2 times a week. And then how would you rate, let's say, our coffee? 1 means that it is consistent of high quality, and 4 means poor quality. So a higher number doesn't mean it's better quality. In fact, it means poor quality. So what happens if you were to move ahead and decide to compute some statistics? Using the same data sets, these are the two categorical variables, can we compute averages? So the average would be 2.26 for how often do you come to work, and 2.6 is for how do you rate our coffee. But you know that 1 doesn't mean 1, and 4 doesn't mean 4 times a week going to work. So these averages are in fact useless and quite meaningless when it comes to categorical variables. The way to represent categorical variable is not through averages, or means, mode, medians, or standard deviation, but through proper tabulations. What we can do is to conduct tabulations to determine how many workers work every day and how many come to work 3 or fewer times a week. And these tabulations could be presented as tables or in a graphical form where there's a hierarchy or there's a logical order in presenting this information. So for example, here you can see every day, 4 or 5 times a week, and then 3 or fewer, and then less than that. So if it's moving from left to right, you understand that there's a hierarchy. Or if you wanted, you can order them in terms of the highest percentage to the lowest percentage. But presenting them randomly, starting with 3 or fewer times a week, to every day, to first time, to 4 or 5 times a week, that's not a good way of presenting this information. At the same time, we would like you to be mindful of using pie charts. If you're working with an ordinal variable such as this looks like income data starting from 0 to 25,000 to all the way to 100 plus thousand. Presenting it in a pie chart does justice to this information. We can't really tell if the distribution is favoring is skewed towards low income, or is it skewed towards higher income. So a bar chart would be a better use in this particular case. And in the case of very simple dichotomous or binary categorical variables such as male and female, the choice is obvious. You present it as bar charts and the frequencies go on the y-axis. This brings us to the end of this video, and Professor Claire and I hope that this will help you advance your learning in business statistics.